I don't know. I thought that it was just a fact.
You may have to prove them as an exam question. Nothing's just a fact. One thing that you can assume, unless they say otherwise, sine squared x plus cos squared x is identical to 1. How can you use that to prove these facts? This one has tan. How do you go from sine and cos to tan?
Divide by cos.
Yeah, so in this case, divide by cos squared x. What do you get?
Tan squared x plus 1 is the same as 1 over cos squared x.
What do you call 1 over cos?
Sec x.
Yep.
Sec squared x.
That's it. And then we just swap those around to make it look like what they wanted it to look like. Any idea how you do the other one?
So there's no normal one this time.
There's always a normal one. What is cot?
1 over tan x.
Yeah. Tan is sine over cos. So 1 over tan would be?
Cos x over sine x.
Yep. And so what would you divide everything by?
Sine x.
Yep.
Sine squared x.
That's it.
So then we get 1 plus cot squared x is the same as cosec squared x.
Well done. And that's in the form that they were looking for. Sine squared x plus cos squared x is identical to 1. That comes from Pythagoras with a unit circle when you have a radius of 1. And you can divide everything by sine squared x or cos squared x to get these two identities. Any questions about that?
No.
Okay. Things about to get weird. Hang on. I'm going to steal these things. Keep them with me. Oh, I might not need them right away. Just in case. No. Like that. There we go. Okay, I don't think I need it yet, but we'll see. How do we do this?
So first you have to find the value of a.
If you like.
So a equals tan to the minus 1 of minus 5 over 12.
Right.
Need to change my calculator to degrees, I think.
You don't, but okay.
Oh.
You can save A as answer.
Okay, so it's like a long number,
Sure.
but it's different to the number I had before as well.
Yep. We want sec
Why?
A. Because centimeters is different from inches. Radians
Oh,
and degrees are different. So they didn't ask you for A. What did they ask you for?
sec A.
How do you do that with your little calculator?
So sec A is 1 over cos A.
Mm-hmm.
So 1 over cos answer.
Give that a go.
I got 13 over 12.
Oh, I like the looks of that one. Minus 5 over 12. This thing's going to make me close two brackets. 13 over 12. Looks good to me. And B.
So do you just do sine to the minus 1 of answer? Or just sine answer?
Yeah, you might have to get that answer again though.
Okay. So is it sine or sine to the power of minus 1?
Use your eyeballs. What does the question say?
Sine A.
Yep. And you said A was some funky thing.
So sine times answer minus 5 over 13.
Okay, what do you get? Oh, minus 5 over 13, was it?
Yeah.
Sounds good to me. Sine of the inverse tan of minus 5 over 12. Okay, we're doing well so far. I hope these signs are correct. And by signs I mean pluses and minuses. Let's see. 13 over 12 minus 5 over 13. Minus 13 over 12 and plus 5 over 13. That was my fear. Okay, the calculator has betrayed us. Why is that? It's because there's some ambiguity. Let me now do some teaching. Let's see. Tan. Sokotoa. What is tan?
Opposite over adjacent.
This is the level I like. Year 9. Tan A is opposite over adjacent. Eyeballs. What's the opposite? What's the adjacent?
Oh, it can't be minus.
I can make a minus. It's going to the left. That's what I'm calling minus.
Oh.
Or it's going down or something. That's going to be my minus. Yeah, maybe I should have drawn this differently. Yeah, I'm going to take that there. It's going to be that one there. So this one is opposite. That's mine. That's angle A. This is minus 5 over the adjacent. That's going to be 12. However that works. Okay. What is the hypotenuse?
Tan A.
Keelan. Year 8. Hypotenuse. 2 sides. 3 sides in a right angle triangle.
5 squared plus 12 squared
Yep.
equals the hypotenuse squared.
There you go.
Wait, so 5. So 13. Yeah.
12 squared. Hypotenuse is?
13 I got.
So the hypotenuse is 13. Okay. What is cosine A? Thinking back to Sokotoa.
Adjacent over hypotenuse. So 12 over 13.
The cos A is 12 over 13. And so what is sec A?
Given
that sec A is 1 over cos.
13 over 12.
13 over 12. What is sine A?
So that we do opposite over hypotenuse, so 5
Not 5.
over 13.
It looks like 5, but it's not 5.
Minus 5.
Minus 5. I hope this is correct. So we're saying 13 over 12 minus 5 over 13. Minus 13 over 12, 5 over... Why, bookie? Why would you do this to me? Okay, my imaginary maths is also letting me down. Looks like I'm going to have to do this the A-level way. We got these things, and I made sure to copy and paste them. Okay. Why must I cheek this man every day? Okay, tan A is this. What is tan squared A? And that's just a fancy way of saying tan A squared. Same thing.
So do you work out tan A and then square it all?
Tan A is minus 5 over 12. And so tan
So
squared.
minus 5 over 12 squared.
Yep. What's that?
I got 25 over 144.
144. Okay. We want to turn that into sec A. Hold on. Alright, we'll do one properly. Then I'm doing the shortcut. So, using our identity, 1 plus tan squared A is identical to sec squared A. We want to find sec A. We said tan squared A is 25 over 144. Calculator. What is 1 plus 25 over 144?
169 over 144.
And so sec squared A is 169 over 144. What is sec A?
Plus or minus the square root of that.
Yep. And I believe it's 13 over 12. How do we know which one? We use our cast diagram.
Oh yeah.
That's what we do. And so here we have a negative tan. Where is tan negative?
In where it's S and C. I can't remember which quadrants they're called.
I don't know. Second and fourth maybe. And so we want sec A, given that the angle is obtuse. So it always starts at the right and opens up anti-clockwise. So if it's obtuse, which one is it? S or C?
C.
I think C would be reflex. Like if this went all the way around there.
Okay.
I think it would make a reflex.
Yeah. Okay, S.
And so it's in this quadrant. And so will sec A, which is 1 over cos, be positive or negative?
Positive. Oh wait, no, negative.
negative. So therefore that is negative 13 over 12. Okay, negative 13 over 12. Okay, my conscience is clear. I have taught you using this Pythagoras method, but at the end we have to use the cast diagram to check. I have taught you using this substitution method and the identity, which is the one they expect you to use. But at the end you have to use the cast diagram. Whatever method you use, you have to use the cast diagram at the end. And so we will just use the cast diagram with a calculator using the easiest method. And if this works, wonderful. If it gives us an approximate answer like a long decimal and they ask for an exact value, then unfortunately we'll have to use one of these. So our question B, let's use cast diagram for this one. We said that tan is negative, the angle is obtuse. Yep. And so we said it was in the second quadrant, and so will sine be positive or negative?
Positive.
Therefore 5 over 13. And that will be our quick way to get positive 5 over 13. Yeah, calculator and cast diagram. That's the quickest, easiest way. Any questions or money?
No.
It'll be real easy. Don't you worry. Don't you worry. Why would you give me an example and then no exam questions on that example? Hang on. Bookie, I know there are exam questions. I've seen a million of them. Why do I spend so long making these things? Cheeky bookie. Let me see. I was afraid I'd have to do this. Yeah. Okay, let's try this.
So first we do tan to the minus 1 over 3/4.
Uh-huh.
And then for sec theta, that is 1 over cos. So we would do 1 over cos answer, which is 5 over 4.
I'm going to write down plus or minus 5 over 4.
Okay.
And lastly,
We have to draw the cast diagram. So if it would have to be in T, and so it would be negative.
Yep. Negative 5 over 4. B.
So this time we just do cos answer instead of the 1 over.
Yeah, your answer will be changed to that. So just you have to re-get that answer.
1 cos answer 4 over 5.
I'm going to write plus or minus. And it makes sense. If sec is 1 over cos, that's 5 over 4 and it's 4 over 5. Sine.
Negative.
Yep.
and then sine answer is plus or minus 3 over 5. And that will be negative as well.
Yep. Minus 3 over 5. Bonus question. Cot theta.
So cot theta is the same as 1 over tan theta. So we do 1 over tan answer, which is plus or minus 4 over 3, and that will be positive.
Yeah. And so those 3 were negative, and so I just wanted to throw in one that would be positive. Any questions?
No.
I said they would be easy. You laughed at me. I told you. Okay. Here we go. Why God? There is no God. There is only trig identities. Okay, here we go. The devil of maths.
So first we have to start by writing out the left-hand side.
Yep. Mine is already written out.
So
Okay.
you have to try and rearrange. No, wait. There's a first step.
This is a very special type. I mentioned this once.
Oh, is it like difference of squares or something?
How did you get so smart? Difference of 2 squares. How did you know that?
I remember you mentioned it last time, but I don't actually know how to do it. I'm not sure.
You are spending way too much time listening to me. Okay, cosec cosec, that's the same as that, yeah?
Mm-hmm.
Which is the same as cosec squared theta squared. Squared, 2 times 2 is 4. And so that is cosec squared theta squared minus cot squared theta squared. And so literally the difference of 2 squares. Something squared minus something else squared.
Okay, so what do you do with that now?
What if it was a squared minus b squared?
Then you would just write a squared minus b squared.
Difference of 2 squares. Factorize.
What do you mean factorize?
You x squared minus 9.
X plus 3, x minus 3.
Yep. And so a squared minus b squared.
A plus b, a minus b.
And now do the cosec stuff.
Cosec theta minus cot theta times cosec theta plus cot theta.
Yep. Just make them all squared.
Oh.
It was to the 4. The squared was on the outside. Cosec squared theta plus cot squared theta times cosec squared theta minus cot squared theta. I need a new page. Okay. Cosec squared theta plus cot squared theta times cosec squared theta minus cot squared theta. Okay, we have identities up here. Which one are we using?
The second one.
What can we do with that?
Rearrange. So 1 equals cosec squared minus cot squared x.
Yeah.
So the second bracket can be written as 1.
Thank the Lord. Okay.
So now you just have the first bracket.
Now we just have this first bracket. Okay. We don't have minus in between, so we're not doing difference of 2 squares. Let's see. We have to make this turn into this thing. This cos on the bottom, I notice, is difference of 2 squares. Is that something? 1 plus cos, 1 minus cos. Okay, we have to turn this into cosine. Let's turn these into cosine. How do we do that? Or in some way involve cos or sine or something.
Cosec is the same as 1 over sine.
1 over sine squared theta. What about cot?
The same as 1 over tan squared theta.
And in terms of sine and cos?
Is it cos squared theta over sine squared theta?
Very good. What is next?
So we're adding that.
Mm-hmm.
Then you can just write 1 plus cos squared theta over sine squared theta.
Mm-hmm.
And we want the sine squared theta to become 1 minus cos squared theta.
And do you know why it is the same thing?
Oh yeah, because sine squared theta plus cos squared theta equals 1.
Yeah.
So we just replace the sine squared theta with 1 minus cos squared theta.
Yeah, and that's where it comes from. So 1 plus cos squared theta over 1 minus cos squared theta. Big picture. It's difference of 2 squares in disguise because to the power 4 is just squared squared. We do that. The second bracket is 1. But when we rearrange our identity, add the fractions. They are in terms of a reciprocal, and the reciprocal, we turn them into in terms of sine and cos because we were trying to turn it into cos. Add and swap, substitute using something similar that we did with that identity. Any questions about that?
No.
All right, let's do it all again. Question B. Oh, you can't see that.
So is it the difference of 2 squares again?
Yes.
So sec theta plus cos theta times sec theta minus cos theta.
Mm-hmm.
Um,
What we're aiming for has sine in it. You know, maybe I don't know. Let's use this identity. Maybe we're supposed to use this identity. Maybe not. I don't know. I do not know. I have some ideas. Let me go on a hunch. Sec squared theta minus, I'm going to go 1 minus sine squared theta. And that's because this has sine and this has sec and this has sine and sec. What does this work out to be?
I don't know.
So that would be sec squared theta minus 1 plus sine squared theta. So there's this sine squared theta times 1. Okay, I'm just trying to not go down a blind alley. There one has second sine. If we were to expand that, oh, that's interesting. So sometimes what helps is to cheat and look at the right side. If you expand this bracket, you get sine squared theta plus sec is 1 over cos. So that would be sine squared theta over cos squared theta, which is tan squared theta. So sine squared theta plus tan squared theta. We have sine squared theta. What is sec squared theta minus 1 the same as?
Tan squared x.
Yeah, tan squared theta in this case.
Oh yeah.
Tan in terms of sine and cos.
Sine squared theta over cos squared theta.
Factorize.
So we want to add them. So
Factorize.
yes. Huh?
Factorize. What do they both have in common?
Sine
Sine
squared theta. So but it's divided by cos squared theta.
So 1 over cos squared theta?
Oh yeah, okay. Plus 1. Oh, and 1 over cos squared theta is the same as sec squared theta.
And then make it look like their one. Sec squared theta. Okay. Let's see. I cheated by expanding the brackets on the right. Sine squared theta plus, that's 1 over cos. So sine squared theta over cos squared theta, which is tan squared theta. So I was kind of like, if I can make our one sine squared theta plus tan squared theta, then I can just work backwards. We had Blah, blah, blah. This cos squared theta, my hunch was change that into 1 minus sine squared because there was sine squared and sec squared in the answer. And then yes, sec squared theta minus 1 is the same as tan squared theta. And then once you have that, then you can just work backwards and pretend you're working forwards the whole time. Any questions there?
No.
Yep. Devilry. What did they do? They did that one. That was alright. And then they did this one. They snaked me. They started from the right hand side and worked towards the left hand side. That's not fair. So right hand side equals this, and then they did that, and then equals the left hand side. Okay. If you get stuck going from left to right, then go from right to left. A brave new world. Okay, these are easy peasy. We'll get to them in a minute. And it looks like, hold on. I thought there'd be more prove that stuff. Okay, most of the exam questions look like the easier stuff. I'm not going to complain. So most of the exam questions are just straight solve the equation. Okay. Oops. Solve the equation.
So we want to change it to one thing.
Nope. We want to solve it.
So like quadratic.
Yeah.
So 4 cosec squared theta minus cot theta minus 9 is equal to 0.
Yeah.
And then do you just type that in your calculator?
If only life was that sweet. Technically, yes. However, I wouldn't be a good teacher if I didn't teach you the method. What is cosec squared theta the same as?
1 over sine theta.
Identity? Cosec squared theta?
1 plus cot squared theta.
Cot squared theta. Simplify.
So should we expand it first?
Yeah.
4 plus 4 cot squared theta minus cot theta minus 9. So then we'll have cot squared. 4 cot squared theta minus cot theta minus 5 equals 0.
Yep. And you can always put those minuses into your calculator if you're not sure. What is next?
Just type it in your calculator.
Yeah, I'm just going to say let cot theta be equal to A. Maybe you don't need that. Maybe you're just doing it in your head. But yeah, calculator.
So 4 cot squared theta minus 1 minus 5. Theta equals 5 over 4 or minus 1.
Okay, so you said theta equals. I'm saying A equals. What did I let be equal to A?
Cot theta.
So it's not theta equals, it's cot theta equals.
Okay, yeah. Okay, so then we have to do theta. So cot theta is the same as 1 over tan theta.
And I'll give you an easy way. If cot theta is 5 over 4, then tan theta is 4 over 5. Reciprocal.
Oh. Okay. So what about if it's minus 1? Just, I don't know.
That's the same as minus 1 over 1. So what's the reciprocal of that?
1 over minus 1.
Yep. Which is the same as?
Minus 1.
Yeah.
Okay.
1 minus 1. These are special numbers. And so theta equals?
We do theta equals tan to the minus 1 of 4 over 5. How many places should it be to?
Let's say 3 sig fig. Are you in degrees?
Yes.
Yeah, go on.
So 38.7. And then for minus 1 is minus 45.
Minus 45 degrees. How do we get additional answers for tan?
You add 180.
Yep.
So minus 45 plus 180, 135. And then 315. And then for 38.7 plus 180, 218.7.
218.7 degrees. And so how many solutions are there in the interval?
5, I think.
There are only 4 because minus 45 is outside the range. Let me see. 4 over 5, 135, 315, 38.7, and 219. Yeah, they rounded it to 219. Great, those are the answers. Big picture. Replace cosec, in this case, cosec squared theta with 1 plus cot squared theta. So you have cot squared theta, you have cot theta, and some number, and so it ends up being a quadratic. And then you solve it the normal way. Watch out for this one. So I let cot theta be equal to a, and then I unlet a be back into cot theta. Watch out for that bit. Any questions about that?
No.
You asked a great question. Can I just put it in my calculator? So put it in your graphical calculator. I'm going to have to put this in as 4 over sine x squared or something. Sine x squared minus 9 alpha equals 1 over tan x, because I don't have cot. 1 over tan x, close that bracket, shift solve. Oops, something went wrong. I forgot to close the sine bracket. That seems like it's not it. That's not it. That's it. Shift solve. Lucky 7. And we get 38.7. That was one of our answers, was it not?
Yeah.
Okay, and then you would add 180 to that, but you would miss out on the other two solutions because it's quadratic.
Oh.
There's the other, there's another reason. Shift solve. I always choose lucky 7. Some silly man says 999. And he gets 1118.7, which I'm sure is correct, but is way, way, way outside the range. And so in order to get the principal value, I know a trick. If you do, this was tan, I'll just use tan, doesn't matter which one you use. Shift tan of answer. And so those two should cancel each other out. And calculator gives me, instead of 1118.7 or whatever it was, these two should cancel each other out, so it should just give me the answer. Calculator's giving me the principal value, meaning the value of theta that is closest to 0. This is an angle in a circle, and you can turn it around as many times as you like our cast diagram. Keep spinning around forever. 30 degrees is the same as 390 degrees. It's going to be 30 plus 360. Both of those lines are going to be in the same place. You can keep adding 360 degrees. Calculator does some magic, finds the principal value. However, it misses out on these two because it's a quadratic. X squared is 9. We say the answer is x is 3, but there's the other possibility x is also equal to minus 3. And that's why we have to keep those in. We have the plus or minus malarkey. Any questions about that?
No.
Okay, if you're really stuck, calculator, get some marks. Also a good way to check your answer, I suppose. Do I go nuts? No, you'll go nuts. You'll put it in your graphical calculator. I suspect that the graphical calculator will get loads of answers. Too many, and it won't be very helpful. But we'll see. Okay. Oh, things are getting weird. Let's try this one. Exam question.
So we have to make them the same, like make cot and cosec the same.
Yep.
But cot is the same as 1 minus cosec squared x.
Mm-hmm.
So we could sub in that to make it all into cosec squared.
Yeah, and I believe it's the way around. Cosec squared x minus 1.
Okay, yeah. So now we have 7 cosec squared x minus 7 minus 5 cosec squared x equals 2. So two cosec squared x. So there's no. So 2 cosec squared x is. No. 2 cosec squared x. Then minus 7 minus 5.
No.
Minus 2. So minus 14 is equal to 0.
No. Minus 5 is connected to cosec squared x. You already did that one.
Oh, okay. So minus 7 minus 2, so minus 9 is equal to 0.
Yep.
And then now do we put it in the calculator or not yet?
Yeah, if you know what you're doing with the calculator.
So, well, should we write let A equal cosec.
I like that. And you always do this, the lowest one. Cosec x, not squared.
Oh yeah. So 2 cos x 0 minus 9. So then A equals 3 root 2 over 2 or minus 3 root 2 over 2.
Okay.
So now we want to get it back to cosec x. Although that is equal to cosec x.
Mm-hmm.
Okay, so to get x by itself, you have to do cosec x is the same as 1 over sine x.
Yep.
So
sine x will be
1 over 3.
Yep.
Wait, what?
Yep. And you could put it in your calculator and it will do keep change flip. Cot x was 5 over 4, so tan x was 4 over 5. Cosec x is 3 root 2 over 2, and so sine x will be
1 over 3 root 2 over 2.
And you could put that in your calculator if you wanted. I won't bother. Just flip it upside down. 2 over 3 root 2. That's what reciprocal means. That's what 1 over means. Keep change flip. 1 divided by.
So minus 2 over 3 root 2.
Although if you put it in your calculator, it will look different because it will automatically rationalize the denominator. The root 2 would probably be on the top. But it would be the same value. Okay, we have sine x. We want x.
So x equals sine to the minus 1.
No, we don't. We want the exact value of cos x. We have sine x. We want cos x.
So we have to do x to equals sine to the minus 1 of those things. And then get an answer. And then do cos of answer.
Yep.
So sine to the minus 1 over 2 over 3 root 2 equals that. So cos of answer equals 0. How many places?
That many, kiddo. So it thwarted us with our calculator, did it?
Pardon?
It didn't let us use the calculator.
Why?
Calculator just didn't get it. Are you using graphical or simple?
Simple, but I have the graphical one as well here.
Try graphical.
So sine to the minus 1 of 2 over 3 root 2. Where's root?
I think it's shift x squared.
Shift. Oh yeah, 2 equals a different number. Wait, does it need to be in degrees?
It shouldn't matter if you now do like cos answer.
How do I do answer on this one?
Oh, is a shift? Yeah, shift, and then the thing that's near execute, bottom right. See it down the bottom right? shift answer. So it's
Oh
like
yeah.
the minus in
I
the word.
see it now. It's the same number, but it's a long number, not yes.
Okay, so they did that to thwart us. So luckily I taught you. Sine x is these things. What is sine squared x? And sine squared x is just another name for sine x all squared.
So you have to square the answer of sine x.
Yep. So 2 over 3 root 2, square the whole thing. What do you get?
Over 3 root 2. Oops. We get 2 over 9.
We get 2 over 9. How do we convert sine squared x into something to do with cosine, which is what the question was?
One over sine is cosec.
Sine squared x plus cos squared x equals 1. And so sine squared x equals
1 minus cos squared x.
Yep. That's 2 over 9. Cos squared x. And so what is cos squared x?
Is 1 minus 2 over 9.
Yep.
Which is just 7 over 9.
Yep. And so what is cos x?
Plus or minus the square root of that.
Yeah. And that'll be root 7 over 3.
Yeah.
X is obtuse. What's that about?
Has to be bigger than 90 degrees, but less than 180.
Okay.
So it has to be an S, so it would be negative.
And so what's the final answer?
Minus root 7 over 3.
Minus root 7 over 3. Did that feel like it was worth 3 marks?
No.
Nope. Sure didn't. Let us see. But. Sec squared x is equal to this. Did I have that one? So you can see for this next exam question, if you swap sec squared x with 1 plus tan squared x, you've got tan squared x, tan x, and some numbers, and then you solve it like we just did. Here you've got cosec squared x and cot x, same idea. You swap cosec squared x with 1 plus cot squared x, and you solve it the same way. And there are many such examples, and probably some other wacky stuff in there as well. Yes, trig identities, x a half or tick.
Half.
There you go. We did our best. So when you can use the calculator, you use the calculator, and we use a heck of a lot, and it did work a heck of a lot. But then there's sometimes where they say exact value, and it's like root 7 over 3. You'd never guess it based on the number, and so you have to use those methods. Let's see. So how was that for you, kiddo?
Good.
What are we doing next time?
I'm not sure because I don't think I'm being set like any new topics after like this week, so we can kind of do whatever, I think.
Okay, and let me just sake my curiosity. There's one more in that chapter anyway, which is inverse trig functions: arc sin x, arc tan x, arc cos x. I say they're easier. Everything is easier than what we just did. It's probably the hardest thing, I think, in A level. And do we stick at this time from now on? Is this easier for
Yeah.
you?
Yeah,
Okay.
it's good.
Okay.
Yeah.
Any questions for me in general?
No.
Okay. Proud of you, kiddo. You did great. Well done. All right. Have a good week. Goodbye.
You too. Bye.